Alright, the purpose of today's lesson is to be able to relate fractions to tenths and hundredths, and this is so that whenever we see a fraction, we're able to quickly understand why that fraction has a decimal equivalent. So make sure that you're on the page that says 79 at the bottom, and you're looking at number 1, and your A problem says 2/5. On the opposite side, it says 1/5. That is not the side that we want to be on, so make sure that you are on the correct side. So take a moment and just double check that you are on the correct side. So when I read the directions, it says shade the fraction, then write an equivalent fraction. So the first thing that I want to do is I want to observe my denominator here. And I can see that we have the fraction 2/5. So the first thing I'm going to do is I'm going to circle the 5, and I want to think about cutting this picture into 5 equal parts. I do see that they have some markings here that will help me be able to cut this easily. So I'm going to count the spaces. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal spaces. But my denominator is only 5. So if I think about taking the number 10 and maybe only cutting every other part, that will give me 5 equal spaces. Let's see if that works. So if I skip 1 and mark this spot, that's 1, 2, 3, 4, and this makes 5. 1, 2, 3, 4, 5. So I'll give you a moment to catch up with me. The next thing that I want to do is I want to shade 2 of the 5 parts because my fraction is labeled 2/5. So I'm going to quickly just shade those 2 pieces. And now this might be a place where you might want to choose to use a pen or maybe even your pencil. So now what I'm going to do is I'm going to relate this fraction 2/5 to the tenth. And so now I need to think about cutting this picture into 10 equal pieces. So I already know that we've cut it into fifths, so now we're going to cut it again. We're going to cut each fifth in half. So we're basically doubling from fifths to tenths. So now I have 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many pieces are shaded out of my 10? There are 4. So we're going to record 4 as our numerator. Looking over at B, again, I'm going to first look at my denominator. I see that my denominator is 5 here. And so just like before, I'm going to have to cut this model into 5 equal pieces. So I'm going to take my pencil and cut every other marking. So we have 1, 2, 3, 4, and that makes 5 equal spaces. 1, 2, 3, 4, 5. I'll give you just a second to catch up. This time my numerator is 3, so I want 3/5 shaded. So I'm going to take my highlighter here. I'm going to shade in 3 of the 5 pieces. So there's 1, 2, and 3. And now I'm going to relate that to the tenths place. And I'm thinking that now that my denominator is 10, I need to go from fifths to tenths. I'm going to need to cut this model into 10 equal pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go back and count those pieces that are shaded. So we have 1, 2, 3, 4, 5, 6, 6 pieces are shaded out of 10. So we have 6 tenths. Alright. And finally, we're going to look at Model C. Model C has the fraction 1/2. And so the first thing that I want to do is I want to acknowledge that our denominator is 2. So I need to cut my model into 2 equal parts. So thinking about cutting this in half, I'm going to go to the fifth tick mark. Hold on just a minute. Let me focus that in. And save right there. I'm going to go to the 5th tick mark. 1, 2, 3, 4, 5. And I'm going to cut that right there and shade in half of my model. Okay, so half of my model is shaded. I want to relate this to the tenths place. So I need to go back and cut my model into 10 equal pieces. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. And what is equivalent to 1/2? Well, that would be 1, 2, 3, 4, 5. 5 of the pieces are shaded. So let's think about relationships for just a minute before we move to the next row. I want you to think about how these are related. I want you to think about by what action can we move from the denominator 5 to the number 10. And I want you to think about what is that relationship from 5 to 10. If you're thinking about multiplying by 2, then we want to keep that relationship multiply by 2 on the top. And 2 times 2 gives you 4. So we do know that these are equivalent to each other. When I go back and look at the fraction 3/5, I want to think about what is that relationship from the number 5 to the number 10. And that is also multiply by 2. And so when I want to think about thinking about taking the number 3 to the number 6, I will also do that by multiplying by 2. So 3 times 2 will give you 6. So it is equivalent. So that relationship is not changing on the top or the bottom. So finally, I want to think about the relationship from the number 2 to the number 10. And if I take the number 2 and I do something and get the number 10, that is to multiply by 5. So if I multiply by 5 on the bottom, I also want to multiply by 5 on the top to show that same relationship. These are all equivalents because they represent the same quantity. We're just renaming the fraction.